Hi students, in this video I am going to talk about the concept of minimum cost function. So in order to understand this minimum cost function, we need to understand the concept of isoquant and isocost. Sometimes it is called isoquant line and isocost line. So now let us assume that a firm uses only two inputs for producing a product, namely labor and capital. And let us say that a unit rate per labor services is denoted by small w, and a unit rate per capital services for the use of capital is denoted by small r. Now again, before we start using this isoquant and isocost for minimum cost function, we need to uh, talk about what is called production function. Actually, this isoquant line is derived from the uh, curve, or from the three-dimensional uh, figure that is obtained using uh, the production function. So the general equation of the production function is given by this formula, which you all know, which means q is a function of labor and capital, where q is the output of production, f is nothing but function of labor, L is labor, and K is capital. The quantity of labor service denoted by capital L, and quantity of capital service denoted by capital K. So in general, the production function looks like this, which is given by this equation, where Q is a function of labor and capital. But in a specific form of equation, then it will be something like this. For example, here Q is equal to 10 into under root L into under root K. Okay, so for any firm, first you need to generate production function equation. So in this case, we are assuming that the firm's production function is given by 10 into under root L into under root K. So from this equation, we can find out for a given uh, quantity of labor, service, and capital service, what is the output Q. So let us take an example. For example, if the firm uses 10 workers, which means L is equal to 10, and employs 10 units of capital, which means K is equal to 10. Here I have made a mistake here, 10. Then if you replace the value of L and K in this formula, then you will get the output of units. Output in units equal to 100 units. Okay, you can see from this. Now, in order to get an understanding of the isocont or derive isocont curve or line, we need to plot this formula for production function, which is Q is equal to 10 into under root L into K on a three-dimensional Cartesian coordinate. So you can see this in the next slide. Here you can see, if you plot the production function equation, Q equal to 10 into under root L into under root K on a three-dimensional Cartesian coordinate, which is made up of labor on horizon on x-axis and capital on y-axis and output on z-axis, then you will get this hill, HILL, hill here, created by this production function. Okay, so on the surface of this hill you can actually draw a contour line. You can draw a contour line for the output of 100 units by joining the points that represent 100 units of output on the surface of this hill. Okay, so then what you can do is you can project this contour line for the output of 100 units from the surface of the hill created by this production function onto the plane of labor and capital. So you can see the line which is projected from this contour line onto the plane of labor and capital, and this line or this curve is called isocont, or just isocont or isocont line for 100 units of output. So if we represent this isocont line only on two-dimensional graph, then it looks like this. Okay, this graph is the same graph which is here, where the z-axis is not shown, where the graph isocont line is plotted on the Cartesian two-dimensional Cartesian coordinate labor and capital. Okay, and the slope of this isocont or isocont line is given by marginal product of labor. In short, it is written as MPL subscript L, marginal product of capital, MP capital M, capital P, subscript K. So the slope of isocont line is given by minus MPL divided by MPK, where MPL is nothing but marginal product of labor and MPK is nothing but marginal product of capital. So now what is marginal product of labor and capital? Then it is given in here. So marginal product of labor is nothing but change in quantity of output divided by change in quantity of labor by keeping the uh, input uh, capital K constant. So in terms of symbol, it is given by this delta Q by delta L. Similarly, marginal product of capital is nothing but change in quantity of output, same as this here, and change in quantity of capital K, while the labor is quantity of labor is held constant, and in symbol it is given by delta Q by delta K. So delta Q and delta Q same. The only difference between them is the denominator delta K and delta L. Okay, so this is about isocont or isocont line. So let us move further and take an example. So let us assume that a firm produces 140 units of output for a given production function of Q equal to function of worker and space. So in this case, the inputs of production are workers for labor and space, square foot of space for the capital K. Okay, so let the isocont for this 140 units of output be as shown in this figure. So this is the isocont or isocont line for the output Q is equal to 140 here. Okay, now if the labor cost W is equal to 500 per week per worker and uh, unit capital cost R is equal to Newton 1 per week per square feet of space, then we can find the total cost of any input combination. So here you can see there are three input combinations. Input combination 1 here denoted by A, input combination 2 here denoted by B, and third input combination of labor and capital, which is square feet of space here. Okay, the combination of input for A, combination of input labor and capital K is given by this. So for A, the combination of input is 2 workers and 2500 square feet of space. Okay, so for this input combination A, we can find out the total cost using this formula. So total cost is nothing, it is just straightforward. total cost is equal to unit rate of labor into the labor quantity of labor plus unit rate of the capital into quantity of capital. So you can see in this example total cost of the input combination A is equal to 1 Newton into 2500 square feet of space, which is nothing but RK plus 500 into 2 number of assembly workers, which is nothing but W into L, and it will give you 3000 Newton 3500. So this is how you can find out the total cost. So you can proceed accordingly for input combination B, where the combination of input is 5 numbers of assembly workers with 1000 square feet of space, and similarly for D. So you can find out. Okay. Now to move on to the isocost or isocost line. The isocost line is given. We can derive the isocost line using the total cost formula, the total cost formula here. Okay, if you rearrange in terms of the capital K, then it will become like this. And this equation you can plot again on the same two-dimensional Cartesian coordinate, where the horizontal axis represents the quantity of assembly worker and the vertical axis represents the square foot of space K. Okay, so on this Cartesian coordinate, if you plot this equation, which you derive by rearranging the equation for total cost in terms of the capital, you will get this equation. Okay, so the slope of this equation is given by minus W divided by R. So this isocost line is nothing but a line along which the total cost is constant. Anywhere on this point, the total cost is constant. And similarly for isoquant line, anywhere along this line, the quantity of output is 140 units. Okay, I forgot to tell you this. Okay, anywhere and along this curve, any point on this curve will give you Q equal to 140. Okay, so for isocost line, any point on this line will give you the total cost equal to $3,500, for example, in this case. Okay, so you can see a set of isocost lines given here. 3 isocost lines are given here, 1, 2 and 3. So you can see this $3,500 isocost line here in the middle, and another isocost line which is giving a total cost of 2,500, which is below this $3,500 total cost, and the $4,500 total cost is above this line. So if you observe this uh, graph, then you can see that the ISO cost line increases in this direction. The ISO cost increases in this line, in this direction, in the northeast direction. And similarly, for the isocont line also it is same. The isocont will increase in the northeast direction. Please remember, like in the case of ISO cost line, isocont also will increase in the northeast direction. Okay, if the output quantity is 200, then it will be here above, not below. Okay, please remember that. So now we can combine these two curves, the isocont curve and isocost line, and find out the minimum cost function. So the minimum cost function, or the solution to the firm's cost minimization problem, will occur at a point where the isoquant just touches the isocost line, or in other words, the solution to the firm's cost minimization problem will occur at a point where isoquant is just tangent to isocost line. So this you can see here in this graph. So you can see this isoquant line for 140 output units of output. Q is equal to 140 units of output. This is tangent to this isocost line, which represents a total cost of $3,000. So the minimum cost occurs at point D here, where the isoquant line is tangent to this isocost line, which represents a total cost of $3,000. So at this point, the combination of the inputs of production is 1,500 square feet of space and 3 number of assembly workers. At this point, it will give you the minimum cost of producing 140 units of output. Okay, so if you take any other point, for example point A along this isocont line, then this will give this combination of inputs of production, 2 number of assembly worker and 2,500 square feet of space. So if you remember, the isocost line, which is placed above this isocost line, has higher total cost. You can see here the total cost of this isocost line is 3,500. So the input combination of point A here will give you total cost of $3,500. $500, which is more than 3000 here, for which the input combination is this 1500 and 3 here. Okay, so the total cost for these 2 points, point A and point B, is 3500, which is greater than this point D, for which the total cost is 3000 only. Okay, so then we can generalize saying that of all the input combination along the isoquant line, point A provides the firm with the lowest level of cost. In this case, actually point D, yeah, I had typed it wrongly, so this is point D. Okay, for this example, the point D provides the firm with the lowest cost. Okay, here also point D. If we take this example, then the solution to the cost minimization problem will occur at point D. Okay, so that means, in other words, of all the input combinations along isoquant line, point D will provide the firm with the lowest level of cost. This point D here is providing the lowest level of cost. Okay, for this input combination at point A, the cost is 3500, and for this input combination point B is also, the total cost is 3500, whereas this point, which is tangent to this isocost line, is 3000 only. So this point D provides the lowest level of cost. So from this figure, what we can draw is that the slope of isoquant at the cost minimizing point D is equal to the slope of isocost line. Okay, so when the isoquant is just tangent to this isocost line, then at this point the slope of isoquant is equal to slope of this isocost line. Okay, so we can write like this: at the cost minimizing condition, the slope of isoquant line is equal to slope of isocost line. So slope of isoquant line, you have seen previously, is given by marginal product of labor divided by marginal product of capital, and the slope of isocost line is given by W divided by R. So slope of isoquant line equal to slope of isocost line, or in other words, at the cost minimizing point, the ratio of marginal product, this ratio is called ratio of marginal products, and this ratio, the slope of the isocost line, is also called ratio of input prices. Okay, so this equation we can rearrange and make like this: MPL divided by W equal to MPK divided by R. Okay, so it is, you can also prove that the point A here, the point A here and point A here, for point A here, the slope of this isocont line is greater than slope of the isocont line here. Okay, so at point A, not E, point A, the slope of the isocont line is more negative than the slope of isocos line, the slope of the isocos line. Okay, so that is all regarding the minimum cost function. Thank you.